So now the next one we're going to be discussing about is what? Cross Aldol condensation. If you talk about Aldol condensation and the required information to gain from it. So the next one we're talking about cross Aldol condensation. So there are following situations we need. There are things that govern cross Aldol. That is, there are things we need to consider when we talk about cross what Aldol. So one of the first to consider is two reactants. That is, in the case of cross Aldol, it requires what? Two reactants, unlike Aldol, just unlike what the Aldol, the ordinary Aldol, where only just one reactant is what is considered. Here we have two reactants, one without alpha hydrogen, and the other with what alpha hydrogen, to give only one organic product in a cross what Aldol. So this is the case. We are giving what two reactants. For example, we have this. You can see that is Aldol condensation involves what two reactants. You can see reactant 1 and what reactant 2. That is one with the alpha hydrogen and the other with what without and what alpha hydrogen. Now let's check. Let's start from here. This is in simple term. It can simply be written as this. You can see there is no alpha hydrogen here, so alpha hydrogen is said to be what absent. So let's consider this. You can see there's a presence of what alpha hydrogen. There's a presence of what alpha hydrogen. So that's one of the bases of what cross Aldol. It contains two what reactants, unlike what the ordinary Aldol, which will only make it of just one single reactant. So it contains two reactants, one with alpha hydrogen and the other without alpha hydrogen. So now the next one to be considered is that condensation between different carbonyl compounds to each what one compound. It also, you can also mix of two different carbonyl compounds just to each what a single compound, and not multiple. And don't forget, in minor product in chemistry, when we talk about product, there is one called the minor and the major product. And the major product is mostly what being considered, while the minor product can definitely be neglected because it is in smaller quantity. So now, we have an example before us. So this is our butanol and our methanol. So this is the example for us. The Aldol condensation of butanol and methanol. So now we can see one has a present and one has a alpha hydrogen, while the other one does not have what an alpha hydrogen. Let's consider the first and the second one. The second one has what no alpha hydrogen, but this one has a what an alpha hydrogen functioning. So now the first one is that to locate the reactant that possesses what an alpha hydrogen. That's the first step. Locate in a cross Aldol condensation. The first step is to locate the reactant with an alpha hydrogen, and you can later make use of the one without an alpha hydrogen in the preceding reaction. So now we can locate that this reactant has the alpha hydrogen. So the next thing is to deprotonate. So this is the alpha hydrogen. So we can deprotonate. We eventually form this. We can see we successfully form our enolate. So we can continue with the second one without the alpha hydrogen. So now the next one is that the enolate attacks the carbonyl group, which causes the localization of pi bond. So which lead us to this. So leading us to this. So we have this CO minus and H. So now the next thing is since we've already formed this, we can link together. Let's link the enolate and link this together to form a carbon-carbon formation ring. We need to link both of them together. So to link both of them together, we have this. Pause. So now the next thing is to what? Is to link the enolate together with this. So let's start our linkage. We have CH3 and our anion at this point. We have C what? H. And don't forget, we have a substituent here, and we will be linking this carbon with this one. So there is no way. This is like a disturbance that will disturb our linkage, so we can just form it as a branch chain. So we can also have it like this, CH double bond what O. So we can see we form a branch chain just to link this point with what? With this point. We have C. So our C, 2 hydrogen, H2, and our what? O minus. You can see we successfully link both together. And the next thing is to what? Is to hydrolyze. We make with use of what? Our H2O. We form a positive H plus and a negative what? OH what? Minus. We need to hydrolyze both. So in successfully hydrolysis of both, it leads us to this. So we successfully form this. So this is a what? A successful cross Aldol what? Condensation. We can see the first step. The first step is we bring in our base. So we bring in what? Our base. Through the cleavage, we have Na plus and what? OH what? Minus. So the OH minus attacks our alpha what? Hydrogen, leading to what? The protonation, which will form what? Our enolate. So the one without the alpha hydrogen, so the enolate attacks the carbonyl compound without the what? Alpha hydrogen, which causes what? The localization of what? Of pi bond. So we have O minus. So the next thing is to form. We need to link both reactants together to form a carbon-carbon bond formation what? Ring. So this is a successful linkage. So after we successfully what? Link both together, so we can then what? Hydrolyze, giving us what? This particular what? Product. So this is a successful cross-Aldol condensation what? Reaction. So we can see this is another example of cross-Aldol condensation. The reaction between benzaldehyde and our butanol undergoing cross-Aldol. So we can just figure out. We can see both. We have two reactants that we can make use of. So let's just consider this and deprotonate the alpha hydrogen at what? At this point. So now let's introduce our dilute base. We have our OH what? Minus. So attacking this point, we can see which leads to formation of this CH3, CH2, CH what? Minus C double bond OH. So successfully form what? Our enolate. The next thing is to what? Introduce this our what? Our benzaldehyde. So we have our benzaldehyde at this point. So we have our benzaldehyde. That is as our usual procedures and steps. The anions attack, the enolate attacks what? The carbonyl group, causing what? The localization of what? Pi what? Electron. So we have this. We have this CO minus H. We can see we successfully form this. So now the next thing is what? Is to form a carbon-carbon bond formation what? We need to link this one and what? And this one what? Together. Very easy and what? And convenient. So this is the pattern with which you do it. So linking both together, we leading us to what? To this. So we need to what? Link this together what? With this. So this one what? A very simple and easy step. So we link both of them together. We have CO minus H, and don't forget this is the point with which you want to link. So this one can be as a branch. So this one can be branched. So they can be branched. So you don't start from here, because this is not the point you want to link. You are linking from this point. So you have CH, and this one is as branch. You have CH2, CH what? 3, and this point. our aldehyde part. We have C double bond O and what 8. We can see we successfully form this. So the next thing is what? Is to what? Hydrolyze. The next thing is what? We hydrolyze. So the moment we hydrolyze, we have this. COH CH2CH3. So you can see this is a successful cross-road Aldol condensation. So now a big summary of cross Aldol condensation, when we talk about, we deal with what? With two reactants. One with the what? Alpha hydrogen and what? The other without what? And alpha hydrogen. As we also between, when we talk about even both Aldol and cross Aldol, the first step is to what? Locate the what? Alpha carbon, the protonate, form the enolate, and you attack with the second reactant, you attack the what? The carbonyl part, and you form a carbon bond for what? Formation ring. So you can see this is what? A successful cross Aldol condensation what? Mechanism. So don't forget what? To like and what? And subscribe so that the video can what? Go more viral.